Hi folks, Tom Affolter here. Welcome to my continuing lecture series on C#, and today we're going to talk about ADO.NET Basics. ADO.NET is Microsoft's technology for connectivity between an application you write, be it in a console application, a website, or a desktop application, that allows, again, connectivity to a database for you to display data, insert, update, or perhaps delete data. So our objectives within this section is, again, a basic understanding of the concepts and the objects and the object model of ADO.NET. And this is going to be our bare knuckles type coding. When I say bare knuckles, we're going to have total control over the connectivity to the database. So the first thing we're going to take a look at is a DNA model overview. Remember that DNA reference model talks about the responsibility of different pieces of software, and we're going to review that briefly. And then we're going to start taking a look at the objects that it takes to make connectivity. We'll start with the connection object. The connection object is how we tell the server where it's located, get to it, log in. Then the command object, which is the command that we're going to send to the server. And then we're going to talk about data providers. Data providers are those entities that give us data back. We're going to focus on SQL Server, but we'll talk about different providers that exist out there in case you're interested in non-Microsoft servers. And we'll talk about data readers and what a data reader can do to us, or for us, I should say. And then we have the execute reader and the execute non-query. The execute reader is used to go out and grab data and bring it back to us, whereas the execute non-query is there to execute a command that doesn't bring data back, such as an insert, an update, or a delete. We'll also talk briefly about bound and unbound data and the concepts of what that might mean. So today's computer or web applications tend to be data-driven. Very few websites that you're going to see out there today or desktop applications exist that do not have some kind of database connectivity. Among the most important skills that you're going to build will be, along with programming, will be your database skills. You're going to find out that many of the job applications that you're going to submit will require you to have some kind of database connectivity. And this is the class that's going to give that to you. At this point in time, hopefully you've already taken the SQL class so you understand the SQL commands. Now we're going to find out how do we implement those in a programming environment. The things that we have to worry about when we're connecting between an application and a database is, number one, where is that data located? We have to specifically know where that data is at, be it a computer name or be it an IP address, as we'll talk about briefly in a minute. We need to know what format is that data in. Is that data in a SQL format? Is it an Access format? What kind of format does that data reside on its server? And the next thing is, how do you connect to that data? Is that data internal to the business, or is that data wide open for the rest of the world? And what do you need to do to authenticate yourself to that data to be able to pull data out? Obviously, there has to be some security behind it, so you can't just leave that data wide open. Then, of course, the next one says, how do you communicate with the source of the data? And that's what we're going to be dealing with now is SQL. SQL is the standard language that we use. It's not the only language that exists out there, but it's by far the most prevalent language that you're going to deal with between database communication. And we'll talk about that as well. And then, how is data request pass and retrieve from the data source? So if I've got an application that's sitting on a desktop and I'm talking to data that might be around the world, when I make that request, how is that data sent back to me? The next item we have to be concerned with is concurrency. I'm not going to go in depth in concurrency, but you need to understand that one of the challenges that you have is if you have centralized data and you have multiple different computers trying to get to that same data, there's always that possibility that two of those users at the same time are going to try to update, change, or delete the same piece of data. And there has to be some kind of methodology for determining whether or not you ignore those kind of errors that come up, meaning that two people are trying to update at the same time. How do you want to handle that concurrency? And we'll talk briefly about that. And then the last thing we're going to look at are, how are forms tied to data? We're going to find out that there's going to be bound data and unbound data. Bound data is usually from a builder, where you do the drag and drop, and a text box is related directly to a field in a table. We don't have to do much of that because the builder will do it for us. Whereas unbound data, we're going to have to deal with ourselves. Now, it's going to be very important from a programming standpoint that you understand both sides of it. This particular module is going to focus on as I said, the bare knuckles, how to make a connection, how to do all the little details from code as opposed to using a builder. In our next section, we'll go back in and take a look at how we can harness those builders to our advantage, but it's more important to understand before we go to the builders what is happening behind the scenes. So what is ADO.NET? ADO.NET is a technology that's been around for a long time. In fact, I think I originally used a version of ADO back in about 2000, and they called it originally just ADO. But when they changed the Microsoft development environment to the .NET environment, they changed ADO from ADO to ADO.NET, and it stands for ActiveX Data Objects. And really all it is a conglomeration of tools that we can use to connect to a database and perform a particular different activity. We need to understand that DNA reference model. Hopefully we've talked about that in a previous class. But you'll remember that there's three responsibilities that software has. It either is presentation, which means that it deals with the look and feel, the interaction between the user. Then we have business logic. Business logic is the guts behind the program. It's really the processing. It's where's the work done. If you have a formula in a program, the formula would be under business logic. And then we have data, and all of these are tiers. So we have the presentation tier, business logic tier, and the data tier. The data tier is responsible for any data connectivity. The important part about this DNA reference model is if you were to take this class from me 25 years ago when I was teaching COBOL, we would have had a one-tier application. That means COBOL did everything. COBOL was responsible for interacting with the user, the look and feel. COBOL, you had all your formulas, your algorithms written in COBOL. It did the calculations, displayed it back to the user, and any data that was being tracked, COBOL had a responsibility of managing that data. And the advantage you had with COBOL, it was one-stop shopping. The bigger disadvantage you had with COBOL is you had to take the good with the bad. COBOL did not do a really good job with the presentation side. It did a pretty good job with the business logic side, but it was really known as in the early days of connecting to data. But it did all of them okay, but it never really excelled at one of these categories. So what ended up happening is as time goes on, that this center tier, this business logic tier, has to be able to get to data. The interesting thing about these tiers, though, is they're all independent technically of one another. When I say technically, there's a little bit of overlap here as we'll talk about, but there's an individual responsibility. The presentation side doesn't normally care what the business logic is doing. All it knows is I've got a responsibility to grab data from a user, and what I'm going to do is imagine you have this wall in between these tiers. That's what this red line is. Presentation tier will do its thing and pass data to the middle tier, the business logic tier. The business logic tier doesn't care that where the data came from. All it knows is something plopped data in my lap. I'm supposed to do something with it, and when I'm done with that, I'm going to send it back maybe to the presentation tier to display the calculations, or maybe I might have to do some database connectivity. So the business layer, or excuse me, the business logic tier here doesn't know who's on the right side of that wall. It doesn't know who the data tier is. All it knows is it needs data. It's going to make a request for data using common tools, and then the data, again, will grab what it needs, pass it back to that business tier. I guess the crux of all this is that each one of these tiers now in the object-oriented programming world are independent. Now, why is that important to us? Well, it's important because now we can pick the best technologies out of all of these different tiers. And let's take a website, for example, that's being written. We might have a website that in the business, or let's go back, in the presentation side, we use HTML5, cascading style sheets, and JavaScript. So between those three technologies, we have that interactive between the users. The HTML5 might have a form that you fill out. The CSS makes that form look good, and the JavaScript might do validation on that form to make sure that if you put in a email address, that it's a valid email address. So if you put in a phone number, it's a valid phone number before anything else is done. In this middle tier, I have ASP.NET, and that's the C# world, or the Microsoft world. But it could very easily be a technology like Ruby on Rails or PHP that's doing it. And if that's the case, my HTML5, my CSS, and my JavaScript in that presentation tier don't care. They're still doing the same job no matter whether it's ASP.NET in that center tier, whether or not it's Ruby on Rails or it's PHP or any other server technology that might exist out there. Now also notice that JavaScript is in that center tier. Sometimes we could use JavaScript to do some calculations for us. So if it does that calculation work and it's not directly associated with the look and feel, it technically would fall under that center tier, that business logic tier. Notice what we've got here on the right hand side now. We have, and I'll be talking about this through the next couple of slides, we have that SQL Server tier. In between, there's got to be something between that ASP.NET and that SQL Server that tells it how to talk, especially if ASP.NET doesn't care if it's talking to SQL Server or Oracle or MySQL or Access or anything else. So where ADO.NET fits in this big picture is that line that goes in between ASP.NET and SQL Server, or the line or that wall in between the business logic and the data tier. We call ADO.NET the data provider. The data provider is that basically it's a translator. It's a translator. When ASP.NET says grab me all these particular records, it's the ADO.NET technology in the middle, that data provider, that tells it how to talk to SQL Server. In this particular case, SQL Server would be known as the data source, or the source of where our data is coming from. What we're going to focus on is this tier right here in the middle, this ADO.NET, or excuse me, that link between the business tier and the data tier in here to get data back and forth. So all those tools that we're going to deal with, again, will be the ADO.NET tools. Why do we want to do ADO.NET? Well, if you were doing this in the old days, it would be very complicated. Microsoft put all those tools together into this ADO.NET package to simplify connectivity. And one of the great things that it does, we'll find out later, is it allows us to maintain what's called a disconnected database model. In the old days of connecting to a database, I would connect to that database when I first started my program. I'd stay connected to that database entirely, and when my program stopped, I'd disconnect from the database. There was a challenge with that though. Microsoft charges by the connection. So if you've got 3 connections, and I think the basic price, and I haven't looked at it recently, was about $1,000 per couple of users. So if you've got 20 users, you're going to be paying a lot of money in those days for connectivity to be able to use SQL Server. Microsoft later changed that. Their technology now is such that you go out, grab the data, it brings it back into your computer, and you manipulate it in memory. The connection only happens for a brief moment. Rather than have to go out there and have maybe 30 people that are working in a database environment have to go out and have 30 connections, I actually can run a database now with 3 connections because I know that these connections happen so quickly. This is a programming technique, by the way, but Microsoft has enabled that for us, that now I can have a 3-user SQL Server and to be able to generally work with as many as 30 different users. So it saved me an enormous amount of money. Another thing that ADO.NET does is it recognizes, the slide says maintain concurrency, but it doesn't really maintain it. It recognizes concurrency, and it can generate an error to let us know we have an issue, and we decide how to deal with that concurrency. Remember, concurrency is when multiple people are trying to get to data at the same time. So let's say, for example, I'm managing dog licenses, and I've got user A goes in and opens up a particular owner's license and makes some changes to it, but they haven't saved their data yet. User B goes in and pulls that same record up. They see the original data but not the changes made because user A hasn't updated his changes. If they make changes, whoever writes data first, only those changes are going to be seen. If a second write comes to that same record, you're going to generate an error, and that's a concurrency error. We won't talk about that in depth right now, but it's important to know that that's a feature of SQL Server. It's not a major problem. I should mention that I've got at Labor's International, I write the software for the Labor's Union. I have an office that has 35 different users in there, and I have 3 connections. And out of those 3 connections that are being maintained, I think, and I track concurrency issues, I have about 60,000 different records. Over the last 10 years, I think I've only had 3 concurrency issues where people are trying to update the same record simultaneously. I have to make a choice. Do I deal with that error? Do I let it just happen? Why would I just let it happen? Well, for me to deal with it, it might cost my client $5,000 or $10,000 worth of my time to go back in and write detailed concurrency to make sure that that doesn't happen. The user has to make a decision. If it only happens once every 5 or 10 years, then maybe that's money not well spent. Again, that's a programming issue that you have to deal with. We'll talk again about that later. So I mentioned a minute ago the data provider. It's that data provider, which is the ADO.net, that is responsible for providing and maintaining the connection to the database. The data provider is a set of related components that work together to provide data in an efficient and a performance-driven manner, which means that they've done a pretty good job of putting these controls together to make it really easy for us to connect to a database. You would think up front that this is going to be complicated, but if you listen to me carefully, you'll find out that this is not very difficult. By default, the .NET framework comes with 2 classes of data providers. Obviously, Microsoft wants to focus on their SQL Server. One of the largest data providers is the SQL Server data provider. But then they also have this generic provider out there called the OLEDB data provider, which will let you connect to all these different databases like Access or Oracle or MySQL if you want. What I'm going to show you right now, even though I'm going to connect to SQL Server, will be very, very similar, if not identical, if you're connecting to Oracle or Access. You'll just have different servers that you connect to, and you'll have to tell it how to talk a different language by using the data provider. But it'll make more sense here in just a second. This slide just shows of the data providers, how are they broken apart. And you'll see that we have system.data, and system.data is a package of tools. They're generic tools out there. They just have what we call data sets and table adapter classes. Then we have the data.oledb. I mentioned that just a moment ago. We have the data.SQL client. That's the tools that we're going to be using right now to talk directly to a SQL server. And then they have ODBC and Oracle clients as well. All of these are the ODBC clients that I talked about a moment ago, with the exception of SQL client here. So these are easy to research though. So each data provider consists of the components of a connection object. The connection object tells your application where's the server at, as well as what the login and the password is. The command object that we're going to be talking about is what's the SQL command that we're going to pass? What do we want to do? And if data is going to be returned, then we're going to use what's called a DataReader object. And a DataReader object sounds like it's a very limited object. It's a read once object. It's kind of like an array that you can only read from one time. But don't let that fool you. We can do a lot of cool stuff with it. And then the last thing that the data provider provides is what's called a table adapter object. In this particular lecture, we're not going to talk about the table adapter. That's the builder objects, which is really, really cool. We're going to save that for the next lecture. We're going to focus right now on the connection, the command, and the data reader objects. So if we're going to look at it from a graphic standpoint here, we'll see that on the left-hand side we have a data reader, we have a command, and we have a connection. And we go from our program, which would be at the very top here, down through here to get to our data and back that same route. So if you're one of those people that like to look at a graphic and understand the layout, this is that kind of graphic here. We'll take a look at these other objects here shortly, but the focus that we're going to have on is going to be in that area right here. So we're going to focus on the data reader, the command, the connection, and then how to get to the database. So notice, from the database we go through the connection object, we pass in a command, and then that data is then placed into a data reader. So let's start talking from the very beginning, and we're going to do baby step examples of each one of these. The connection object. The connection object is very important. What it does is it identifies the type of connection that we're going to deal with. It identifies the startup database that we're going to connect to, and then a login and a password if applicable. Now what does that mean? Well, if you have a local database like in Access or in SQL Server Express, you may not have a login and a password for that. You may just get to your data directly. So you don't have to always have a login and password. But the fact of the matter is, folks, the vast majority of what you're going to deal with is going to be a login and a password. Let me explain what we've got here on the screen. You'll notice right here I've got SQL connection con. what this is doing, and both of these are doing the same thing, both examples I have here, but let me explain them separately here. The first one creates a new connection object of type SQL connection. So this is like declaring a variable, but I'm declaring a connection object. So from now on, once I do this top line, I'm going to refer to my object as CONN, just like you see down here. So here, this just sets aside the memory for my SQL connection. This next line now goes back in and actually adds the connection in. So notice what I've got is I've got connection is equal to new SQL connection, and then inside here, this is what's referred to as my connection string. And the connection string starts off with the data source. What's my database server? Where's my data coming from? This will either be, if I'm inside of an organization, in a domain, in a network, this might be a computer name, but the vast majority of the time you're going to find that this is going to be an IP address right here. You're going to connect, or it could be a domain name out on the internet, but it's going to point directly to a computer that's on the internet. Then you've got this thing called initial catalog. This is geeky. I wish they would have called it database, but initial catalog is what's the database that I'm going to connect to. When I get to this location, what's the database I'm going to connect to? And the next line is my user ID. What do I log in with? And what is my password going to be? So that's one method. That's a two-step method here. I could combine all of those into one step, because I could have said here, SQL connection, and instead of putting con here, I could have just moved all of this up exactly as you see here. So here I'm creating the connection, but at the same time I'm applying that connection object to it. Let me go ahead and open up an example of that. To open, let's see here. Let's do our first example, which is a connection object. So again, trying to do baby steps on here. So all I'm going to focus on right now is the connection object. Going out there, logging into a server, submitting my password, and then opening that connection, and then ending at that. Okay? So let's take a look and see what's behind this connect button. There's nothing in here. It's very simple. So behind this connect button, when it decides to open up here, this is showing you different methods of doing the same thing. You should be able to figure out what I've got going on here. First thing I do is I create a string, and in that string, I'm going to hold the connection string. Right here, notice that I've got this connection string here. The next line down, I'm doing a new connection. So this is what's creating a new connection in memory. This statement right here is setting aside the memory that it needs for it. This guy says, as you're setting aside the memory, take all of the methods, all the properties that exist in a SQL connection, and copy it in at the same time. As this class goes on, we're going to understand this part in detail, especially in about another 3 weeks. But that's what creates the CN object that now has everything I need in it. Here, I apply my connection string. So what I'm telling it is my SQL server is located at 134.391.7335. That's the SEC SQL server I use. The name of the database that we're going to connect to is called DemoGuest. The login to DemoGuest is DemoGuest, and the password is Demo. The next thing I do is I apply that connection string into my connection string property here. So I'm saying take this connection string and move it into the property. Now before I go on, I could have done it a couple of different ways here. Let me go through this, demo it, and show you an alternate way of doing exactly the same thing. I'm going to put a stop right here. We're going to watch this program run. So let's start it. It's compiling. Now I'm going to click the connect. And now launches that event handler. I'm on this first line. If I look at CN right now, it's no. It's never been assigned yet because it hasn't run this line. So as soon as I step through this line, okay, now it says, oh, now I know what CN is. It is a SQL connection. So the next line now I've got this string. It's just a simple string here, and I'm giving it to a variable that I've declared up here. So I'm going to step over that guy right now. Boom. So now I'm going to move this string into my connection object using this method right here. Okay. Step past that. It now knows that the connection string is, as you see here, that statement that we just added in, and now I want it to open that connection. It's going to go out to that SQL server, it's going to open a connection up, and now that connection is open. And all I'm going to do immediately, in between here, I'd be doing something. We'll do that in just a second here. But right now, I'm simply going to close that connection to show I could do that. And boom, now I'm done. So the connection was opened and it was closed that quick. Let's take a look at an alternate way of doing exactly the same thing. Let me stop my program here. You jump me into my code behind, don't want that. And an alternate way of doing exactly the same thing is taking the string and this method right here, I can pass into the connection string right in those parentheses. So basically I could take this guy right here, I can do a Control X, pull him out, paste him right here. Now I'm feeding that connection string directly into the object. I don't need this line any longer. I don't need this line any longer. And I certainly don't need this line any longer because I'm feeding it directly. So let's see if this is going to work. Let's put our stop back over here again. Let's rerun it and see how this is going to work itself out. Which is the better way, by the way, as we're compiling? Either way is the best way. The best way is the one that makes the most sense to you, that you feel the most comfortable with as a programmer. So here's the application. Let's connect. Okay, I'm sitting, let's get back to my code here. I'm sitting on that line. Let's step over that line, make sure it works. It worked. Let's see if it opens it. It opened it, so we know that's an alternative way of doing the same thing. This is a little bit quicker if you like that method. Otherwise, I could pass it in as I did before. Let's go back in. Let me Control Z out of this and go back to where we were. There we are. What we had before was I opened the connection, didn't tell it what the connection string was, created a variable, put the connection string in that variable. Then the connection has a property. The equivalent of putting it in between the brackets is applying to the connection string property of that object. And I can prove that. Watch this. If I do a cn dot, there's my connection string right there. And you'll see a bunch of other opportunities we have in here. One of them is a connection string timeout. By default, I believe it's a 30-second timeout, but if I think for some reason it's going to take my server a long time to reply, I can increase that timeout period if I want to. And that will prevent a timeout error from occurring perhaps. Let's go ahead and get rid of that. That proves that that's there. Then once I apply it, I can just simply open it. So there's your basic connection string, folks. That's a pretty easy object to deal with. Now that data source you just saw was going to a SQL server, but it could go to an access. If you take a look at the example that I have on the screen here, I've got it going to a Northwind example of a database here, but it can go to a variety of different components. And I should also point out that the code that we're doing right now, that code that we just looked at, would be the exact same code if we're doing a web application, if we're doing a desktop application, or we're doing a console application. They all look exactly the same. The purpose of creating a connection object is so that you can enable other ADO.NET code to work off of a database. So really that's the opening of the door. That's shaking the hands with the server to let me get to that server. So what it does is it instantiates the connection, it opens up that connection, it makes it available for us to do whatever we want with all those other ADO components that we're going to take a look at next, and then we simply close that connection out when we're done. It's very important to close the connection when you're done because you can come up with what's called a memory leak. A memory leak means that you're actually using RAM that is not being given back to you. If you run this over and over again, it's actually possible to not, with today's memory, it's hard to run out of memory, but it's certainly easy to make your program start running a lot slower. So this is going back and showing the shortcut option that I just mentioned. Here's an example on this slide right here of using a local database. If I've got a local database like Access and I've added it to my application, then rather than referring to it by the IP address, I simply put the word local here. Then I tell it what the database is, the local database. In this case it would be Northwind, and I can open it that way. So if you're connecting again to Access, Fox Pro, SQL Express, you could use a local if you wanted. Also, here's a really good site if you want to know how to connect to different types of data sources. You could go back out and there's a site called connectionstring.com, and this whole site is geared to do nothing but tell you how to connect to different sites out there. So you'll see here it tells you I can connect to a SQL Server 2005, which is pretty old, how to connect to Oracle, MySQL. These are the connection strings that you could research out if you wanted to go to non-Microsoft databases. Now let's talk a little bit about the command object. We've taken a look at how to make the connection, but we got to figure out how do we tell SQL what we want to do. And it's, again, we'll find these commands are basically structured very similar. you'll see here that I'm creating a brand new command object with this, and it's going to work with a connection. So look at this. I've got a new command object I'm creating. Then I take that command object right here and I apply a new SQL command, and I'm passing into it the command that I want to run. In this case, I'm getting all the records back from customers, and then at the very end of it, notice I put a comma here and CONN. Why CONN? That's the connection that we previously created that tells it this is the connection that you're going to use to pass in this SQL statement right here. So that's one way of doing it. This second method down below here, take a look at what I'm doing. I'm doing it in one swoop. I'm doing a SQL command is equal to a new SQL command. I've got the select statement here, and then a comma and the connection that it's using. Let's take a look at an example of that one here, and let's open up a new one here. So project solution, command object. And now it looks very similar to what we had before because I'm building on the previous example that we have. So if I come back into test here and let's take a look at what's going on, I still have my SQL connection that we created just a moment ago. I still have that open. So this is what we did previously. Now what I've done is I've added in a SQL command. And this SQL command just says to go out there, use this connection right there that I created. There it is right there. And I want to pass into it a SQL statement that's going to bring back all the records from this TBL zip table that I have out here. I'm not doing anything with it yet. I'm creating the command and I'm going to close that connection. I have to figure out what I want to do with the data that's going to be returned from that. We haven't dealt with that yet. But let's make sure that this guy is going to go ahead and work as well. Let's go ahead and run it. Test. Okay, it says it worked. I've got my click me button here. Why is it not getting my click me button? There's my code. Let's try that again. Why did my stop not work? There it is. Apparently it didn't recompile. If you take a look, let's look at the code here. I'm creating a new connection. I'm telling it where the data is at. I'm passing that into that connection string property so it knows how to connect. I'm opening a statement. Boom. There it is. So now at this point the connection is open. Now I'm creating a new command, and the command says get all the records from table zip and use the CN. But I'm not doing anything with the data yet. I'm actually not even executing this statement yet. We'll do that in a moment. So let's just make sure that works. It says it did, and let's close that connection out. Excellent. Baby steps. And so far those baby steps have worked just great. Now, here's some examples of the command object using what we call parameters. One of the problems that we have, and if you've taken my SQL class, you remember we talked about SQL injection. SQL injection is a method that hackers can use to go back through an application that you write and hack into your data. I would suggest if you're not familiar with what SQL injection is, if you didn't take my SQL class, then you go back out and you do a little bit of research on it. There is a way to block SQL injection, and this methodology is how to do it on the screen right here. So you'll notice I've got a SQL parameter called param here, and it's a new SQL parameter. And then I'm giving it a parameter name of @city. So what I'm doing is I'm creating the values that I would be inputting into a select statement, if you will, so that I'm not concatenating them together. In the old days, I would have used this bottom method down here of concatenation, but this concatenation method we see at the bottom here opens the door to SQL injection. You can't use this method. If you do, you're going to cause some major problems for your application, and it would be very easy to hack it. So what I'm doing now is I'm going back in and I'm saying I want to select all the customers from a particular city. I'm creating a new parameter and I'm going to call it @city. You have to put an @ symbol in front of it. And the parameter value is going to come from some variable. So this input city is coming from a text box maybe. It's coming from some place the user has input this. I don't have that in the application yet. I'm assuming it's being passed in. So that's what the value of the parameter is going to be. Notice what happens down here is I now create my command object, just as we did before. In my command object, I've now put @city in. See, before I would have had to go back in and use a text box and concatenate it together, but now I'm simply referring to it as @city, and it's going to move whatever this input value is right here into @city. And I'm using the connection that we would have previously created. And the last thing that I have to do before I execute this command is I need to add that parameter in. If I don't use this statement right here, this guy's going to fail because he's going to say, I don't know what @city is. I've created it here, but I haven't added that parameter to my command. And there's my command right there. Keep an eye on this. We're going to need to come back. We'll play with these a little bit later. I will have an example of this for us to look at. Now let's talk a little bit about the different types of commands that we can deal with SQL. There's two basic classes of commands. Either we intend to get data back or we intend to do something with data. What's an example of that? Well, a select statement says I always get something back from a select statement. But when I do an insert, update, or a delete, I get nothing back. Those are two different types of statements that we're going to deal with. One statement that expects a value to be returned. That generally comes from a select statement or maybe a stored procedure. Or those statements that I expect to be just a do it type statement. I want to do an insert, I want to do an update, or I want to do a delete. And how we deal with those are different in our statements. We have two different elements that we're going to deal with. One is called an execute reader, and the other one is called an execute non-reader. An execute reader is used when you expect to get data back. We're going to grab that data back, and as we'll find out, we're going to store it in some kind of a container object. The container object that we're going to store it in is what's going to be called a data reader. But for right now, let's just focus on the fact that an execute reader executes a statement that returns data back. An execute non-query simply executes a statement and says, I don't expect anything to come back. If there's an error and inserting, updating, or deleting, the execute query will give you the error. But if everything works fine, it just executes that statement. And we're going to take a look at two different examples of those. Let me jump over and do that before we jump into this next slide. So first thing let's do is let's open up a different, I better stop this guy from running, and let's open up a different project. And the first one we'll do is let's do an execute reader. So an execute reader is expecting to get data back. In this case, we're going to use what's called a data reader. And a data reader is an interesting object because what it is, it's kind of like an array where you can read all the data and you can put it inside. But an array, you can jump around and look at values. In a data reader, we'll find out that you can only read top to bottom. If you read the first item, the second, and the third, you can't back up and read the second and the first again. You can continue reading down, but it's a read forward only element. You can't read backwards in it. Well, it sounds pretty restrictive, but the fact is we really only use a data reader for a brief moment. If I want my data to be editable, then what I'm going to do is I'm going to take that data from a data reader and I'm going to move it into maybe a grid, and that grid then will allow me to move up and down, but the data reader won't. So let's just take a look at this code and see what it's going to give us. I've got this list up here, this list object. So it's simply a list control. It would be a control from right here, a list box. This guy right over here on the right hand side. I dropped it in, and what I want to do is I want to read data out of a zip code table. So let's take a look and see what's happening here, and let me come back and select my pointer and let's look at the data. So this is the first working example that we have. So if we step down the line, again, we have our connection just as we did before. We create our connection. We open the connection. We now create our command object just as we did before. And notice here, I'm going to bring in all the zip codes from the state of Washington. I haven't created a parameter object because it's hard coded in. I only want the state of Washington at this point. The next thing I do is I create what's called a data reader. A data reader. So this statement right here is what creates that data reader object. It's a SQL data reader. And before I go on, I should mention one thing that I didn't mention before. For me to be able to write this program, I had to add in, by me adding this control in right here, it saved me from having to type all of this out in front of my commands right here. So let me show you what I'm talking about. If I comment this guy out, I'm going to get a whole bunch of errors down in here because it's going to say I don't know where SQL connection comes from. I don't know where SQL command or SQL data reader comes from. So I put that back in there because where the SQL connection comes from is it comes from system.data.sqlclient.sql connection. So I could have done this. I could have taken all of this code, put it right here, and it would have worked. But doggone if that doesn't look very complicated. So rather than have to do all of that, what I do is I go back in here and I add a reference to a package. These packages, by the way, already exist over in my references. There's my data right there. They already exist. I'm just making shortcuts that make my code easier to run. So watch this. If I come back in here and uncomment this guy out right here, this guy still works because I'm taking the long way. I'm telling it where to find that command. But by stripping this out now, what's going to happen is when this program, when I execute this statement right here, it's going to say, I don't know where SQL connection is. Then it's going to look and say, is it in system.data? Nope. Is it in system.drawing? Nope. System.text? Nope. System.windows.forms? Nope. Is it in systems.data.client? Yes, it is. And then it will know where to find the command. So it's just a shortcut. That's all it is. But if you don't put it in there, you got to put that entire namespace in front of it, and that's just a pain. Getting back to our code then. All the way down to here, we've already looked at that. Here I'm creating a statement. But now, what I'm going to tell it to do is, now that you've got this command, I want to execute that command. And when it reads all that data, I want it to throw it into this container right here called reader.zip. Think of it kind of like an array, but not an array. Again, as I mentioned before, because I can load it in there, but all I can do is read one row at a time. But that's what I'm going to do down here. This guy will execute the reader. And what that does is that positions the pointer in my database at the top of first record to be read. And then the way I read one record at a time is with this statement right here. Now notice what happens is if I've got 3 pieces of data to be read, okay, the first piece of data is going to be read. It's going to fill the data in. We'll talk about this in just a second. The next piece is going to be read. The third piece will be read. But when I issue the next read, it's going to say, wait a minute, there's no more pieces of data to be read. It's going to jump down here and it's going to close out the database or close out my connection. This reads one record at a time out of that reader.zip control. Let's play with it and see what happens. Let's run it. And before we do anything, let's just see what it's going to look like on its own. Let me take the stop out. Let's go back in and just run it. Test. Uh-oh, we might have an error. We have an error in here. So, and I think, what was the error message that came up? Zip code table, and one of the column names are incorrect. And I will bet you that this table now uses the column name, and we'll come back and dissect this in a minute. These are the column names that it's reading back in. It's reading the city. And where did this come from? Look at this. All those columns were from here. So it's reading the city, the state, and the zip columns out of that table, and it's putting it back in to that list box. This is that item, that add we looked at in the Introduction to Programming class right there. So I believe that that column is called zip. So let me see if that's the case. Oh, I got to stop the program. Stop it. Let's see if this takes care of it. You saw that error that popped up though. That's going to be important. We're going to deal with that shortly in this class. Let me clean this up just a little bit. Let's rerun it, see if that took care of it. If not, I'll have to go back and look at the structure. Test. Boom. That was it. And again, there it is. It's pulling out all the data. Look at all that garbage data at the very top of this. It's pulling out all the data that it thinks are from the state of Washington. How did it do that? Let's watch how it reads that data. I'm going to put a stop right here this time. So by the time it gets to this line, it will have opened up the command. It will have positioned its pointer at the top of the data and wait for me to read each record one by one out. Okay, so let's try this again and see what happens. Hit the test. Okay, so now I'm going to issue a read. It's going to grab the very first record. That's that garbage data we saw at the top. Let's just see what it reads. So I'm going to use my step to step through this. Right there, it's in that line. I could actually ask it what it just read. Watch this. If I take this statement right here, all the way down, and what trim does is it gets rid of spaces at the end that might be there. So I'm going to take that guy, I'm going to drag him down to my watch window right here and watch what happens. See what he pops up. Spokane. And if I grab this guy and I drag him down to the watch window, he's showing you exactly what's being read. Washington. What reader.zip says is when you bring back a row of data, it's going to be brought back as reader.zip, that row of data. And you parse it out by saying, within this row of data, pull out the city portion of it, convert it into a string, put a comma after it, grab the state portion of it, put a space after it, grab the zip code. At the very end of that, once you've got that string put together, let's see what it puts together for that first string. Boom. Spokane, Washington, 00124, that was garbage data. Somebody played around with that table. Now the next thing it's going to do, it's going to add it to that list that we have on our screen. It's going to add Spokane, Washington, 00124 to that list. Watch this. We'll step into that, and it added it. And it's just going to keep going through that loop, adding all of these records in one at a time. Let's stop it and see which one it reads this time. Well, let's go through a couple of times, because I know there's some garbage data at the beginning of it. Okay, let's see what it's read this time. My string is Spokane, Washington, straight ones that time. Let's go again. See what the last thing it goes through. Let's run it. I'm going to continue. So what I can do now, instead of stepping, I can hit the continue, and it will continue until it sees this next stop down below. And if you don't know how to use stops, folks, and you don't know how to step through your application, you're doing yourself a big disservice, because this is the only way to go when it comes to debugging your applications. It makes life so much easier. Okay, let's run it. And now everything has been filled in at that point. If I wanted to go back in and read what's in reader.zip, now I can't do that. Why? Because I can't read backwards. I'm done reading it. If I want to get back to reader.zip, I have to run this entire chunk of code again. But let's see what it's done again. Oh, I got to take that stop out. There we go. There it is. It's closing the connection out. It's done. And there's my data in there. Look at it. You can see there's a lot of garbage data in here. Spokane, Washington, Bodunk, Washington, Spokane, Washington, all kinds of garbage data in there, which we could delete out later with what we're going to learn in our next module. So let's go ahead and jump back over to our PowerPoint slides. And let's talk briefly about the concept of bound and unbound data. What we just did is we dealt with unbound data. If I was to go back to that list box, I'm populating that list box directly. I could put anything in that list box I just had. There's no relationship between that list box and my database directly. The only relationship is that I just read the data out of that database and I put it myself into that list box. That makes it unbound. Bound data, though, is we're going to take a look at, not in this module, but in the next module, is a really cool feature of the drag and drop that allows us to go back in and marry a particular field with a field in a database. So I can come back and say this last name text box is directly related to the last name field in my database. So when I make a change in that text box, basically I'm making a change in my underlying database. Not quite that simple, but pretty doggone close. It's a very easy method when we're dealing with bound. It's drag and drop. I think you'll like that, but we're going to take a look at the doing it by hand method first before we get to the builder stuff. The data reader in a data set. We won't talk about data sets specifically now, but these are the two containers that we use within a database. A data reader, as we just talked about, is like an array, but it's read only one direction. You can only read a record one time. You can't read backwards. Whereas a data set is really a lot different. A data set is a database that's been brought in basically into memory. Think of it that way. Think of a data set as if I went out and grabbed all my zip code data, I could bring all of that entire table and dealt with it in memory myself. Now, what's the advantage of dealing with it in memory? It's a lot faster to deal with it in memory than it is dealing with it on the server. But there's a lot of problems with dealing it in memory as well. That concurrency issue can really come up when we're dealing with it in memory, but we'll find out later that these data sets are extremely, extremely powerful. We can read and write to a data set, and the data sets will already, in most cases, have its insert, updates, and deletes built for us by the designer. Talking a little bit more about that data reader object. The data reader object is, in this case, is called RDR. So just going back through the techniques on this is I create my command. I've got a connection created somewhere. And now if I take this command, CMD, I execute the reader for CMD, and I'm placing all the data that comes out, whatever this select category from categories is, into this RDR data reader that I've named it in this particular case. I want to pause and come back to this execute reader application we've got here and reanalyze it again one more time, because there's some things I'd like to point out. First of all, notice this execute reader here. The execute reader expects to get 0 or more records returned. So we're executing the command. Which command are we executing? We're executing this command right here. When that data is returned, it's going to be returned to reader zip, to a data reader object called reader.zip. It's going to be a stack of information, either zero information or a stack of an infinite number of records that might be returned. The next line down tells us that we're going to read. This is how we code right here, folks, if we're doing a one-to-many relationship. One-to-many. Well, what happens is when this data reader sends back the information and populates reader.zip, a pointer, think of it as a fingers pointing to the very first record, is set. The moment we issue a read, that record is read in, and we can parse it out. So the moment I issue a reader zip.read, we're asking it read where that pointer's at, and at that point it strips out the information. I can come back in and say, give me back the city information, or give me back the state information. Here I'm asking specifically for the column name that exists within the field list that we would have with this asterisk. But I also could come back and list it out numerically. So I could put a 0 in here for the very first column, or a 1 in here for the second. Again, for those people that took my SQL class, I recommend against that, because at any point in time, if the structure of this table changes and you have these numerically entered and it throws the numbers off, all of a sudden this statement stops working. Whereas if you're using the column names in here, as we are, then you don't have to worry about it. So let's continue on now. If I wanted to change this to be a one-to-one relationship, okay, then what I don't have to worry about is these multiple reads. I know with a one-to-one relationship, there's going to be a single read. So what would that look like? How would that differ from this? Well, if it's going to be a one-to-one relationship, then I don't have a loop. So I'm going to take this out. I'm going to take this statement out right here, move these back over, and there you go. Oh, let me put my semicolon in here. And at that point, that would allow me to do a one-to-one read. And think about it, it makes sense. I position my pointer, there's only a single record that's going to come back. I read that single record, I position my pointer at it, and then I just read that record that was brought back in. The only issue that might happen here is if no records have been returned, meaning that you expect it to return a record back, but no records come back. That would generate an error, because a one-to-one relationship expects one record to be returned for every parent. It doesn't expect 0 records to come back. So there is another way that we could bypass that, and I can use an if statement, and then I can do a reader zip dot has rows, and I can simply put that in, embed that in an if statement like this. And that way, I've eliminated, oops, let's try this, get rid of that. I've eliminated the possibility of that error occurring. And real quickly, if you don't know this already, if my code is out of whack here because of alignment, I can come back over to Edit, Advanced, Format Document, and it will reformat the document for me. There's an example of how I would deal with it on a one-to-one relationship, just to make sure no error has occurred. Before I go on, I also want to point out that the list box that we're using right here, I'm adding every item that comes through this, whether it's a one-to-one relationship or one-to-many, one item at a time back to that list box. I could be adding text in here, but I'm simply reading this string and I'm plugging it into that list zip codes items collection, which means that this is an unbound data. There is no direct relationship between this list box and the database that I'm connecting to. I'm just using this to display information back. So again, we would refer to that as an unbound relationship. So let me come back and let me Control Z and get us back to our original code here. Give me just a moment. And I think that takes us back. Now what I'd like to do is go back in and let's play around with that topic we talked about briefly earlier, parameters. Right now, it's expecting the state of Washington to be fed in. What if I would like to make this a little bit more flexible, more variable? I'd like to be able to pass any city in, or excuse me, any state in that I have. So let's go back to our application here and let's modify it just slightly. Okay, I'm going to go ahead and throw a text box on here right now. And what I'd like to do is whatever state that I type into that text box, what I'd like to do is then have only those zip codes for that respective state show up when I click test. So let's see how I can make this happen. First thing I'm going to do is go to my tab order, make sure I have it correct, first item, second item, and then the last item. Although I could really exclude this. I don't need to gain focus to this guy, so it's not a big deal. So let's turn off my tab order again. Let's go back into the test. And now what I want to do is I need to create parameters. So I've got this command right here, and I need to create a parameter that can attach to that command so I can replace Washington. And what I want to do is replace Washington with some kind of a parameter variable. Parameter variables start with an ampersand, the @ symbol. So what I'd like to do is take this guy out right here, and I want to replace it with, let's call it @state here. Something like that. Anytime @state is plugged in here, it's going to make it replaceable parameter. So let's add the parameter in. And as long as I do it before I execute the command, I'm in pretty good shape here. And there's the execute right there. So the next statement I'm going to do is a SQL parameter. SQL parameter, it pops up as IntelliSense. I call mine param. You can call it anything you want. Is a new. I want all the properties that parameters have. Oops. Let's try this. Equals new SQL parameter. Right there. So now I have this parameter object. I want to come back in and I'm going to say my parameter name, parameter dot parameter name is going to be equal to, and this is where I define my @state. I'm going to call it @state. The next thing I have to do is tell it where to get the parameter value from, and I want to grab that parameter value from this text box. Let's give it a name. Instead of text box 1, let's call it text state. Looks cleaner in the code. Come back to our code here, and now I want to say that parameter dot value is equal to whatever's in text state dot text property. Right there. Now once I get that done, I need to tell it, right now this parameter is not associated with this command. Notice nowhere in here does it reference command. This is a standalone object right now, so I need to add that parameter to that command, and that's another easy command here. Command dot parameters dot add, and then the name of the parameter, like that. So let's review again what I did. Let's spread this out a little bit. Here's my basic command. I went back to my command, took out the hard-coded state equals Washington, and I replaced it with an ampersand, and what I'm going to have is a replaceable parameter. Down below here, I've created the parameter object. I call it param, right there. Then I take param, I give it a name, and by the way, I could add in multiple different parameters. I'm not stuck with one parameter. As long as they all have different values, I could plug anything in that I want here, or at least different parameter names. So once I create that parameter, I can keep adding in more if I'd like. At that point, I've created the @state. That's the relationship between these two guys right here. And then the next line down is I said I got to give that parameter a value. What is @state going to be equal to? And it's going to be equal to whatever's in that text state text box. So let's go ahead and run this and see if it's going to work. Okay, let's try our original Washington test. There's all the Washingtons. Let's try Oregon test. Uh-oh. Why did Oregon not work? Did this not recompile correctly? Let's find out. So I went ahead and paused for a moment to try to figure out what my problem was, and I really thought initially that my issue was going to be with my parameter object, because again, going back when I run this, let me just review what's happening here. If I put in Washington and I test it, I would get Washington, but if I went back in and I put in Oregon and I tested it, I would get nothing back. But if I ran this from scratch and I typed in Oregon and I test it, the Oregon works. And now if I type in Washington and I test it, the Washington appears not to work. So I thought again that the problem was going to be within my parameters, but as it turns out, that's not what my problem is. My problem is that I've got this list box and I'm not clearing the list box in between. So if I go to the bottom of this, there's my Washingtons. They were here all along. So what I really need to do is I always have to make sure that before I start writing back to that list box again here, somewhere above this, I need to clear that previous list box out. So let's do that. LST, list zip codes dot, let's see, is there a clear there? Nope. So let's do items dot clear. There we go. That should solve our problem right there. Let's go ahead and run this again. Let's put in Washington. There's Washington. Let's put in California. There's our Californias right there. So it's working great. There's no relationship between this list box and the database. I'm just using this for output right now. So let's continue on. Let's take a look at another example. Let's open up a new project. This time, let's take a look at the one here, execute non-query with a delete. A little bit more than a delete there. Okay, another application we have sitting here. So right off the bat, you'll notice that we have an insert, we have a delete feature. I'm not sure what that delete feature does. We'll have to go back in and take a look at that. That was created in the past. And I have an exit button here. So I'm assuming that what this is going to do is allow me to insert a value into my zip code table. This is where that garbage data came from probably in the past. Let's take a look at the code. On my insert statement here, okay, notice that this time, because I want to be able to use my connection string in a variety of different locations, I would need to use it behind the insert button and behind the delete button, and I don't want to put that string in twice. So what we've done is we've taken that connection string and we have made it a class level variable. We put it up at the top of the program outside of an event handler. We've also made the connection itself a class level variable connection. And the SQL string that we're going to use, we've made that class level as well, because we know we'll need to be able to get to it in either one of these buttons. If I was only going to code the insert button and not a delete button, I might be able to get away with doing it all internal. But this is going to save me a bit of coding right here. Right off the bat, I make the connection string equal to CNSTR. That's that connection string we identified globally up here. I open the connection. Well, wait a minute. Where's that connection at? That's also set up globally right here, CN. So it was already instantiated or created at that point. So we open up the connection. Now notice that I'm using an insert statement here and I have no parameters. This should have parameters. This is not the best way to do it, but this is a very simple way to explain it. I'm doing an insert into table values, the zip code that I entered, and I'm not doing any error checking, by the way, folks. That's why some of that data that we saw before was garbage type data. I probably won't want to do error checking, make sure that the zip code is truly numeric, unless I'm dealing with Canadian zip codes, which are alphanumeric. I want to make sure that a city is entered, and I want to make sure that the state is entered as a 2-digit state. But we're not here to focus on validation right now. We're here strictly to focus on the SQL aspect of it. I've now got that insert statement created, and notice what I'm doing now. I'm inserting. There's my command right here, the SQL command. Remember, it took 2 arguments before. It took the SQL statement first and then the connection object second. I'm feeding in the SQL statement right here. I could have taken this entire insert statement and replaced it right here, but I think it's a little easier to read this way. Again, that's one of those 6 of 1/2 dozen of the others. And now notice right here, I'm doing an execute non-query. An execute non-query says, this is going to be a command that I execute that I'm not going to read anything back. There's no read command. I'm just saying do it. The insert statement doesn't return anything back to me. It just inserts a record. Let's see what else we've got. There's a delete here as well. So it looks like the delete is reading the delete value out of the zip code table. So how the delete works is we're using that same connection string we had above. We're opening that same connection. This time we're deleting from zip codes where the zip code is equal to some, and we'll pull up one of those bad zip codes and we'll delete it out. Then I've got the command. I identify the command, the connection, and then I execute it. I close it out, and once I close it out, I empty out all the information that's in the city, state, and zip text. I didn't need to do that. Probably shouldn't have been anything in city and state. If this program was written a little bit more efficiently, I wouldn't allow that both to be my insert and my delete. I would have a zip code delete text box most likely down here. But for demonstration purposes, this will work. So let's go ahead and run this thing. In fact, before I do that, I think I'm going to go ahead and open up that previous one. The one that we were looking at just before, the execute reader. And the reason I'm going to open it up is I want to pull out a couple of bad records that we might want to delete out. So let's go ahead and pull up Washington, because we knew that there were some bad ones in there. And it looks like there's a 00124 and a 00126 and a 00127. And boy, and even look at the validation. There's a 1, a 111, a 111, and then straight 5 ones. Those are all bad zip codes. In fact, look at all the 2s down below. So there's quite a few bad zip codes at the top. I just needed to pull some out, so let's stop that. Let's go back to that previous query with the delete. So now we know what we want to deal with. Let's go ahead and let's run it, and let's delete out a couple of bad ones. First, let's just simply pull up a bad one. We'll delete it, make sure it works. And you'll see that the challenge with this is it's not going to give me any valid message. It's just going to act like I just clicked the button, I believe. So let's come back over here, and we have that one in here that was a single one. Okay, I want to delete that out. Uh-oh. Execute non-query. And I know why. It's because there is no column called zip code. It's called zip. Notice this error right here. This is very important because it's telling us what kind of error that we had. Very shortly, within one of the next exercises we work on, we're going to talk about how to trap those errors if we haven't already. Because we might want to come back in here and specifically look at that SQL error and tell the user a SQL error occurred and be able to specifically identify the type of error. But for now, let's just leave that alone. Let me come back in here and correct this. That should simply stay zip right there. So let's make sure that's correct in the other one as well. Insert into it values. Yep, we're doing a values. We're not doing a field list up here. So I think that would work. Let's find out. Let's rerun it. Put 1 back in again. Delete. And nothing happened. But it didn't give me an error, which meant now that it deleted it. If I go back in right now, let's try putting a 1 back in and see if I can generate an error by deleting one that shouldn't exist. Nope. And the reason is how does it know that it didn't exist? It just went out there and deleted a record out, but if no records are there, it just continues on. It doesn't generate an error if a delete doesn't exist. So let's trace this again. Let's watch what it's doing. So we're on the delete. We'll stop right there. Rerun it. This time we're going to delete the 111. Delete. So we're sitting on the line here to run through it. The connection string it's going to apply is that global variable from above. There it is. So it's added the connection string. It's going to open the connection. It worked. Now it's going to define to a string the SQL statement. What's the statement look like? You can always highlight it, and there's what it looks like once it's been derived. It's got that 111 in there. So it's delete from table zip codes where zip equals 111. We're now creating the command, and now we execute the query. If there was an error in it, like we saw before with zip table or zip column not existing, we'd get an error. But right now, it's going to delete all the zip codes that are equal to 1. If none existed, it's not going to generate an error. There it is. It finished it. It closed the connection, and it's wiping out city state, and it's wiping out zip. So there's an example of the delete working. Let's go back in and add that same zip code in that we just put in. So let's try Colbert, Washington 111. And now we're going to insert it. Before I do that, let's go back and watch the insert work as well. Let me take these stops out. And we'll put a stop right here. Let's rerun it. Insert. So the first thing it does is it applies the connection string. There it is. Where's the data coming from? It then opens that connection with the login, the password at that location we identified. I now create the insert statement. Boom. If I point to this, you'll see there's the derived insert statement that it's just built for me. Okay. Create the command. Now let's execute it. Uh-oh. And it says the column of or number of supplied values does not match the table definition. And the reason that that is, folks, is if I was to go back in, and I don't believe I have it open. Do I have it open right now? I do. Let's go back and look at that zip code table. That's under actually that was under demo guest. Demo guest, tables, zip codes. And we're going to see in here that we have more than 3 columns. This new table actually has a latitude, a longitude, a time zone, and whatever a DST is, which means then that we'll have to go back in and we'll have to fill all these columns in with something, or we have to go back in and give it a column list. So let's go back and give it a column list. So we just need to add zip, city, and state to that demonstration. So let's do that. Right here, let's stop it. Oh, and I should probably go back and make one other verification. Zip, city, state, specifically. And let's make sure that, oops, let's jump back over to that zip code table here. And let's reopen zip codes again. I want to make sure not null, not null, not null. Good. So if you look at the requirements here, it says you have to fill in a zip, a city, and a state, but you don't have to fill in the latitude, the longitude, the time zone, or the DST. But that only works if you're using a column list within your insert statement like we just did. So let's go back over to that and make sure it's going to work this time. Let's rerun it. We're going to put Colbert, Washington 1, 2, 3. Insert it. Okay, we'll watch it, see if it's going to work this time. Open it. There's our statement. Let's see what it looks like. Zip code, zip, city, state, values. Looks good there. Let's step down. Let's execute it. And it liked it. It executed it, and it put it in. What we didn't do, though, is we didn't erase the code. We should have probably erased this once we inserted it and maybe even positioned a cursor back here. We didn't do that. But the opportunity that I have now is, because it's only looking at that field, I can simply hit the delete, and because we're still in the step mode, run through it, and that record now was deleted out. Pretty cool stuff on how that works. I think what I'd like you to do, and I'll probably give this as a homework assignment, is to go back in and turn these into parameters. Make these out to be parameters. But we'll talk about that later. Let's bring up another example before we break away off this section. Okay, I'm going to open up and execute query with a search. And let's see what this guy's going to do for us. This has got the insert and the delete from the previous, but we've now added a search button and a zip code to find down below. So I'm assuming we type a zip code in, we click search, and it's going to find that zip code for us. Let's find out. So let's type in 99217 and see what it brings up. I didn't even read my own code. Let's try this, 99217, tab out of it. Same thing here, we got that same problem. That table's been changed, it's no longer called zip code, it's called zip. Oh, let's stop the program. Let's make that correction real quick. And right here, we'll come back and talk about this as well. Again. And let's take a look while we're here and see what this search button is going to do for us. All the search button does is enable that zip to find below. So all it's doing here, let's rerun this, is there's nothing visible down here until I click search. Then these buttons are disabled. Now I can type in the zip code that I want, 99217, tab out of it. I think it's a leave event on it. And we got the same problem. Oh, there it is right there. I didn't correct it. You folks probably saw that and didn't yell loud enough for me to hear you. There we go. There we go. Yet again. So we're going to search 99217, hit the tab to tab out of it, and there's Spokane, Washington. Search. Probably should clear that out. 8, 4, 5, tab out of it. My hometown, Telluride, Colorado. And then of course I could delete it, and if I deleted it out right now, then I'd be deleting this out of the entire table. I don't want to do that right now. But keep in mind though that when you're playing with this data, you might find a lot more garbage in it. That's why I have a backup of it. I always try to replace that every quarter when a new group of students come in. So this one allows me to search, insert, or delete any kind of zip code that exists out there. And let's go back in and just investigate a little bit how that search works. Okay. So the search simply goes back in and it enables the it disables the delete button. It doesn't make it invisible. I could make it invisible, but I'm simply disabling it so you can't click it. Disabling the search, the insert button. Then it's making the label find visible, and then it's also making visible the text box, and then it's setting focus in that zip code to find. Now I've got, when you leave that zip code, this is the code that runs. So I've got a leave event on it. You type in a zip code, you hit tab to get out of it, or you click out of it. This code's going to automatically run. It's going to grab the zip code that you just typed in to that text box. It's going to put it in a select statement. It should find only one record to match, a one-to-one relationship. So I shouldn't have to loop through more than one record. I should expect that only 199207 has a city. It shouldn't have 5 different cities that pop up from one zip code. So that's what I'm doing. I'm issuing a single read, which positions the cursor on that single record that's returned back. I verify that there's not an error. Did somebody type in a weird zip code that doesn't exist? If they did, then below I want to say zip code's not found. But if they didn't, if there are rows that were returned back, means that there was at least one row, then I grab that and parse the data out. I said, take a look at what's now in that reader where the pointer's at. Grab the city column out, plug that in the text box, text property for city. Plug the state into the state text box, the zip code into the zip text box. Then close out. And at that point, let's set everything back and make that find no longer available. Resets that find. Everything else is the same as the previous example we went through. I could have put a button over here rather than a leave event and made it so you type in a zip code, you click the button, and all the code would have been behind the button. But I simply made it just to show a different type of event handler behind that. Now, of course, there's all kinds of chances for errors in here that we haven't addressed, that we'll have to address at some other point. One example might be something like this. If I go in and I do a search and I tab out of this without putting anything into it, zip code not found. What if I put a letter in and I tab out of it? Not too bad yet. But the challenge comes in is I can put any kind of garbage up here. There's nothing to tell me that when I go back in and I do an insert that I can't come back and have garbage for everything. Everything. And we need to put some error checking there later to make sure that zip code is 5 digits wide, or perhaps if you want to do extended zip codes, but at least 5 digits. All of them are numeric. We want to make sure that the state, either we feed them in a combo box, which we could do, all the possible states, and they click on the state that they want, or at that point, we have to validate that it's 2 characters. Perhaps what we might want to do is something else, making sure that our data is consistent, is do this. Come back over to character casing and make sure that our data always, no matter how we type it in, it's always going to be uppercase. That makes our data standard, because from a data standpoint, uppercase data and lowercase data sort differently. So let's go ahead and continue on with the lecture. So even though it appears to be pretty limited, the DataReader object that we're going to play with, or we've been playing with, is extremely powerful. I told you before that it's a read only one direction. You can read only top to bottom. We've already seen that, but we can also manipulate that around. Let me show you what I'm talking about. This is that example that we had before where we're throwing the data back into that list box. So let's rerun that application. I'm going to type in Oregon, and I'm going to click test. Now notice what it did is we looked at before. It populated this with Oregon, but what I now can do with this list box is something that I could not do before with that data reader. The data reader is done with. It's populated this list box and it's finished. Now the list box though has the data and I can maneuver back and forth with it. But keep in mind that this is a read only application. In addition to what we just talked about, that data reader can also be used to apply towards a data grid viewer. A data grid viewer is a little bit more powerful than what a list box is, although I'm not sure if I would use the data grid viewer with unbound data as we're doing right now. I will show you in our next set of lectures how powerful this data grid view is and what the cool stuff you can do with it along with the database. But I can apply my data, if I want to, back into a data grid view using the code that I have here. So before I go on, this is an example of a data grid view, and the underlying control for a data grid view is it wants to be related to what's referred to as a table adapter or some kind of a table object. So that's what I'm going to do initially is I have to in memory create a new table object. In this case I'm creating a data table. I'm going to call it my table, and then I take my table and I load it with the executed command that we had before. Once I do that, then I can take my table, which now has my data in it, and apply it back to that data grid view. Let me see if I've got an example for us to look at. Yes, I do. Take a look at a demonstration of this first. So what I've done is I've gotten rid of that list control that we had before, and I've replaced it with the data grid view. Notice that this is what the data grid view looks like by default if there's no data assigned to it. So now I'm going to go ahead and put a state in here. Let's put Oregon in. I'm going to click test. And now what it's done is it's populated that data grid view. In fact, it's populated it because I've included the wildcard on it. It's populated with the entire table. Oops. Let's go back to that run again. The entire table. See how everything is over here? So if all I want to have is zip, city, and state, I need to go back in and modify my code right here. All I want is zip, instead of everything, city, and I want state. And probably the other thing that I'd want to do is expand this grid a little bit to make sure I can see everything. So let's make that grid a little bit wider. Let's rerun it and see if it's going to work this time. Should have only bringing back 3 columns. Let's see. And there it is. Oh, and you know what happened is, because I didn't fill any data in, here's some garbage data that somebody didn't use a state on. Let's put a state in here. Let's put in California. Test. And there you go. You have all the California data. And of course, you could go back to your select statement if you wanted to and change the order of it. So right now I've got it in zip code order. I might want to tell it, you know, I'd like to order by, let's do a city, then a zip. Let's rerun it. California should be a compo action. So you'll see they're now in city order. If I jump down, I'll see all the Los Angeleses together. There it is right there, all the LAs together in zip code order. But also notice that at this point I don't have a lot of control over the grid. But in our next section we talked about bound data, we do. And before I go on, this in fact is bound data. You'll notice that what I've done here, going back, is I have now bound that table to that data source. So there's a combination of unbound and bound in here. The bound aspect of it is that I'm populating this table with all the data, and then I bind the table back into this data source. So there's that direct relationship right here between the two. The other thing that we can do, we've already looked at before, is we can assign the contents perhaps to a text box. So I could read the data, and there's examples that we've just gone through on that, where I can say, give me back the fourth column. That's, in geek terms, 3 is the fourth column, 0, 1, 2, and 3. Give me back the fourth column of my data that is in this data reader. If this was the data, it would give me back 1, 2, 3. It'd give me back this column right here, the last name column. Otherwise, I could, and I suggest this method down below here, is ask it specifically by column name. So you include the column name in here. You would have to put in the exact column name that your table has to pull that out. And then of course, here's the last example, and this is using a console application, which this works just as well in console application as it does in a desktop application, or as it would in a website, by the way. Here we're looping through. We're assuming now that we have populated that data reader, and we're going to step through one by one, pulling all that data out of that data reader. So we talked about the execute non-query. Remember, it's a do it type query. It just says go back and do an insert, do an update, do a delete. This should say delete on the screen. I will correct that. It's used with non-bound ADO techniques. So non-bound means is that you're manipulating it. You have total control. Later when we use the builder is going to do a lot of the work for us, but at the same time we're going to lose a little bit of control over that data. You have absolute control when you're using these methods that we have here, although to try to produce what the builder will give us later would take a massive amount of time. We're going to find out that that builder is going to be a great friend for us when we do need to create the larger applications, the related tables, if you will. You can design complete websites. You don't have to use any of the builders that I'm talking about. In fact, a lot of the websites that you're going to see that use ADO technology or that use ASP technology will use ADO, and they don't use a lot of builders. There are some available, but in most cases on a website you're going to do a lot of by hand type coding, and again you have a lot more control with that. You'll use DataReaders, and that's going to be to retrieve data, select from a combo or a grid, or edit from an execute non-reader, and then you're going to use the execute non-reader to insert or update that data.